Hey guys, welcome to CPM 3. This is lesson 5. We're going to be solving equations containing fractions. So, example 1, we are solving these three equations. So in the first one, A, we have 1/5 x equals 8. So in this one here, this one's actually pretty straightforward. This little bar right here on that 1/5, that little bar just simply means divide. So the opposite of dividing by 5 is to multiply by 5. So we'll multiply this over. And what we do to one side, we have to do to the other. So now that we know our fraction rules, right? 5 times 1 right here on the top is 5. All over 5, that cancels out to be 1. So those go away. I'm left with 1x, or just x. And then we have 8 times 5, and that's going to give me 40. We are used to seeing that problem instead of being 1/5 x. We were solving it when it looked like x over 5 equals 8. So those are the exact same equations, just wrote in a different form, right? Because there's a 1 right there in front of that x. So it's that 1/5 x. Okay, now in the next one, you can do this two different ways. You can do this all in one step, or you can do it in 2 steps. So I'll show you both. If we start with the long route, again, this bar right here just means divide. That's 3 divided by 5. So the opposite is to multiply by 5. And again, what I do to one side, I must also do to the other. So my 5's cancel on this side, and I'm left with a 3a. So we have 3a equals 9 times 5 is 45. And now since that we're multiplying by 3, the opposite is to divide that 3 over. And so I get a equals 45 divided by 3 is 15. Okay, so those are your 2 different steps. I started with that divide by 5, so I multiplied, and then we had 3 times a, so then we divided by 3. The other way to do this, I'm just going to rewrite the problem over here. 3 over 5a equals 9. Okay, the second way to do this is to do it all in one step. And to do it all in one step, we are going to multiply by the reciprocal. Let's say multiply by reciprocal. So remember, the reciprocal means we just take this fraction and flip it. So instead of it being 3 over 5, now I multiply by 5 over 3. And again, what I do to one side, we have to do to the other. So here, my 5's cancel, my 3's cancel, so I'm just left with a. Here, I'm going to cross reduce, so I can reduce 3 and 9 by 3. So 9 divided by 3 is 3. 3 divided by 3 is just 1. So I have 3 times 5, which gives me 15. Okay, so it doesn't really matter if you do it in 1 step or 2. Get the same answer. I personally like this 1 step, but it's up to you. So, do the same thing on this one. You can either do your 2 steps. If we did 2 steps, that bar just means to divide. So the opposite of dividing by 6 is to multiply by 6. So cancel, cancel. I'm left with 5x equals, I can cross reduce here if you put this over 1. Yeah, if you put this over 1, 6 and 9 are both divisible by 3, so 6 divided by 3 is 2, 9 divided by 3 is 3. So I've got -1 times 2 to give me a negative 2, and 3 times 1 to give me 3, and then divide by 5. Divide by 5 over here. My 5's cancel. This one, however, because we have a fraction, now I need to use my division rules. So if I put this over 1, to divide fractions, you got to use your keep, change, flip. Keep the first fraction. Change your division to multiplication, and then flip this, which just means the reciprocal. So now we can multiply straight across. You can't reduce anything, right? 2 and 5 are prime, 1 and 3 are prime, so just multiply straight across. So negative 2 times 1 is negative 10. No, it's not. Sorry, negative 2. And 3 times 5 is 15. So look how much work we have there. Let's do this all in one step. So we're going to have to use a little bit of this part D's area, but I've got 5 over 6x equals a negative 1/9. Okay, so let's multiply by the reciprocal here. So reciprocal just means flip this fraction. So instead of it being 5 over 6, it is now 6 over 5. And what I do to one side, I'm also doing to the other. So here my 6's cancel, my 5's cancel, and I'm just left with x. And then over here, I'm going to cross reduce. These are both prime numbers. Can't reduce this way, but I can reduce going this way. 9 and 6 are both divisible by 2, or no, by 3, sorry, by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So multiply straight across. Negative 1 times 2. And 3 times 5. So as you can see, a lot less work if you just multiply by the reciprocal. Okay. Now for part D, since I kind of ran out of room and used too much of my room, I'm going to kind of move this one over here. So I've got 3y. 3y equals a negative 2 over 11. Okay. So all right, so this is kind of going to be like this portion over here. To get y by itself, we have to divide. What I do to one side, I'm doing to the other. So I'm dividing by 3. We got to use our multiplication rules. So I'm going to put this over 1. And we've got to use our keep, change, flip. So I'm going to keep my first fraction, negative 2 over 11. I'm changing my division to multiplication. And then we've got to flip our second fraction. So instead of this being 3 over 1, now it is 1 over 3. Cross reduce if you can. These are both prime numbers. These are both prime numbers, so I can't cross reduce anything. So just multiply straight across. I'm going to get y equals negative 2 times 1 is negative 2. And 3 times 11 is 33. So I get y equals negative 2 over 33. Now, I don't know if we're going to get a lot of fractions on the next couple of pages, but you can see here we got 1, 2 fractions. So it's okay to get fractions as your answer on these. So don't think you did them wrong just because you didn't get a whole number. Now, this first page is going to be a little bit different than what we're going to do on the next page. If you notice here, everything was just being multiplied. You had a fraction times x, or like on this one here, you had something times your variable equals a fraction. Okay, but these have all been one-step equations, either just multiplying or dividing. When you go to this page here, the second page, now if you notice, you have a fraction plus a whole number equals something else. So we've got a two-step problem here. So it says solving an equation with fractions can be tedious. If an equation contains fractions, it is often helpful to first multiply both sides of the equation by the LCD of the fraction. This has the effect of eliminating fractions in the equation. So step one, we need, if fractions are present, which, spoiler alert, they're going to be present all today, multiply both sides of the equation by the LCD, and then the rest is the same. If we have parentheses, we're going to use distributive property. We're going to combine like terms. Step 4, you want to get your variable term on one side and your constant term on the other side, and then divide. Okay, so in A, what is my LCD with 6 and 3? So I'm going to end up erasing this portion of it, but list them out. Okay, if you, hopefully by now you're getting kind of used to this LCD, especially if you've practiced last lesson, and you can just see what it is. But if you can't, list out your multiples. My LCD, we have 6, which is 6 times 1, 6 times 2, 6 times 3. 3 is 3, 6, 9, 12. Because it is the LCD, the least common denominator, what is the smallest number that both of these have in common is going to be 6. Now again, hopefully you can honestly just start looking at these and see that that's what the LCD is. But I'm going to just write right here, my LCD is 6. Okay, so once I figure out what the LCD is, I need to multiply both sides of the equation by whatever your LCD is. And not just both sides, but every single term. So like in this one, you've got 1, 2, 3 terms. All 3 of those terms need to be multiplied by this LCD. So I'm going to do this the long way on this one, maybe even the next one, but then we're going to start doing this a little bit shorter, okay? But on this first one, you have x over 6, and now I need to times this by 6. And if you want to, you can put this over 1. So when you multiply, your 6's cancel. So when you multiply straight across, you have 6 times essentially a 1. And a 1 times a 1, x over 1 is x. Okay, and this might actually be better if I don't put this over 1 for this particular one. Your 6's here cancel, and all you're left with is an x. So this one here now just becomes x after I multiply it by 6. Okay, times this one by 6. 6 times 1 gives me 6. And I'm bringing down that plus that's right there in the middle. And now I need to multiply this one also by 6. So here we've got 4 over 3 times 6. Same thing, cross reduce. This way here, 6 and 3 are both divisible by 3. So cancel out your 3, make it a 1. Cancel out your 6, make it a 2. So then when you multiply straight across, you have 4 times 2, you're going to get 8. Now I have just a simple equation, and now I can solve. So we got x plus 6 equals 8. The whole point of multiplying everything by this LCD is to eliminate every fraction. Did I get rid of my fractions? Yes, I did, so it served its purpose. So now we can solve. So the opposite of adding 6 is to subtract it. So I get x equals 2. Okay, let's try again. So on B, find your LCD. Again, I really hope that you guys can look at that and see what your LCD is. But in case you can't, list out your multiples. My 5, that's 5 times 1, 5 times 2, 5 times 3, 5 times 4. For 3, we've got 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. I now have something in common, that 15. So here, my LCD is 15. So that means I need to multiply every term by 15. Okay, now that looks super messy, so I'm not going to do it in parentheses, but everything's getting multiplied by 15. So on this first one, if I have 15 times z over 5, you can do it one of two ways. Multiply straight across. If you multiply straight across, let's put that over 1. So 15 times z is 15z. 1 times 5 is 5. 15 divided by 5 is 3, so 3z. Or make this even easier on yourself and cross reduce. I can't reduce anything with that z, but 15 and 5 are divisible by 5. So 15 divided by 5 is 3. 5 divided by 5 is 1. So we get 3z. Okay, do the same thing with this negative. Actually, I'm just going to bring that negative down. So then let's do 15 times z over 3. 15 times z over 3. Here, we can reduce both of those by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. So when you multiply straight across, you get 5z. Now the common mistake is going to be that you guys will just say that equals 6. But if you multiply one of these things by something, you've got to multiply everything by it. So we've got to do 15 times 6. So over here, 15 times 6, we get 30. Carry your 3. 1 times 6 is 6, plus the 3 is 90. So, multiplied everything by that LCD. Now I've gotten rid of all my fractions. That was the whole point. So now solve. On this one, we need to use step 3. We need to combine like terms. These are both like terms because they both have a z. These were not like terms because they didn't both have an x. So 3 minus 5 gives me a negative 2. Bring down your z equals 90. So now I need to divide both sides by 2. And write this a little bit smaller. So we'll get z equals If you don't know what 90 divided by 2 is, we'll come over here. 2 goes into 9 4 times, multiply it back out, subtract, we get 1, bring down your 0, 2 goes into 10 5 times. So we will get a negative 45 since we have positive divided by negative, different signs. Okay, now I'm going to go a little bit quicker because I'm not going to write out down here the multiplication steps. If you're not familiar or practiced enough with multiplication, you either need to practice your multiplication first or go watch the video if you haven't seen that lesson. On B, what is your LCD? Well, if you only have one number in the bottom of these fractions, that is your LCD. So my LCD here is 13. So I'm not just multiplying one thing by 13, not just the fractions by 13, multiply everything by 13. We've got 1, 2, 3 terms. I need to multiply all 3 of those terms. So this first one here, when I multiply by 13, 13 times y is 13. Bring down your minus. 13 times 3. My 13s are going to cancel, and I'm just left with the 3. Equals, and then multiply this by 13. Again, my 13s cancel, and I'm just left with a negative 2. So, get y by itself. So, the opposite of subtracting 3 is to add 3. So I get 13y equals, different signs, subtracting, keep the sign of the bigger number, 1. Last step is to divide by 13. Now please be careful here. 1 divided by 13, that doesn't reduce. So I get y is 1 over 13. 13 over 1 is 13. But if 13 is on the bottom, you got to keep it that way. If you feel like you're getting this pretty well, I would suggest that you guys pause this video and try this one on your own. On this one, you're going to multiply all 5 of these terms by whatever your LCD is. So if you want to, if you feel comfortable, try pausing the video and seeing if you can do D by yourself. Okay, so hopefully pause that video. Let's get into this. So first, you've got to find your LCD. This is one of those ones again. These all have the same number on the bottom, so that means that is your LCD. Multiply everything by that 11 though. So 11 times 5x is 55x. 1 over 11 times 11. Your 11s cancel, and you're just left with that plus 1. Times this by 11. 11 times negative 4 is a negative 44. Bring down your x. Equals. And I'm going to back this up to scoot this over. Okay. So that's the left side. So now the right side, multiply this by 11. Again, your 11s cancel. And we're left with 2 minus times this by 11. Your 11s cancel again, and we're left with a minus 5. So again, multiplied everything by its LCD, got rid of all the fractions. That was the goal. So now we're right here to step 3. I need to combine my like terms. So on the right side, or sorry, on the left side, we have a 55x minus 44x. Keep that sign in front. So 55 minus 45 gives me 11. So 11x plus 1 equals, on the left side, these are both like terms, so let's combine those. So 2 minus 5 is a negative 3. So now get x by itself, so we need to move that 1 first. So we're going to minus the 1 over. I get 11x equals negative 4. Divide by 11. You can't reduce that since 11 is a prime number, so x equals negative 4 over 11. And this is, of course, the same as just like a 4 over a negative 11, or you can even make that negative neutral. Doesn't matter where that negative goes as long as you have it and it's only there once. Okay, so now we're about to do on this next page a combination of multiplying by the LCD and this one here of when you just need to multiply or divide by a fraction. Really and truly, what we were doing on this page though is multiplying by the LCD, right? And this problem, and this first problem here, the LCD was 5. We multiplied by 5. On B, the LCD was 5. We multiplied by 5. On C, the LCD was 6, and that's what we multiplied by. And then on D, well, we didn't do that on D, but we did do that on A, B, and C. Okay, D was its own thing. So it does not matter if you wanted to use the LCD on everything that involves a fraction, or if you want to kind of go the shortcut move that's on this page here. Okay. All right, so on C here, that's not numbered correctly. A, B, C, D. Ooh, that was supposed to be a C as well in red. A, B, C, D. All right, so this is E. This should be F. This should be G, E, F, G, H. So the H is good. Okay. I don't know what happened there. Okay, here on E. Okay, on E, that's a bad E, but on E, we have 15x minus or equals 11. There's no fraction here. Just solve this. 15 times x equals 11. So how do you get x by itself? We need to divide this 15 over. So I get x equals, can we reduce? Well, no, because 11 is a prime number. So I've got x equals 11 over 15. Okay, now in F, we've got a couple different choices. You can solve F the way we did on this one here. Here we just divided by 3 on both sides, right? Divided by 3. And then now because I have a division problem, we had to change that to a multiplication problem by your keep, change, flip. Keep the first fraction, change your division multiplication, flip your fraction. So it being 3 over 1, it's 1 over 3. So since we've already solved 1 this way, let's solve this one the other way. The other way would be by the LCD. So your LCD would be the only fraction that we have, which is that 6 over 11. So 11 is your LCD since it's on the bottom. So multiply every term. This one only has 2 terms, right? But you're multiplying everything by 11. So when I multiply my negative 3x times 11, we get negative 33x. Then multiply this one by 11. Your 11s cancel, and it equals a -6. So then, to get x by itself, now it looks exactly like what this one was. Divide everything by -33. So I get x equals. Can you reduce? Yes, you can. So first off, your negatives cancel, right? Negative over negative is positive, and then we can divide both of these by 3. So 6 divided by 3 is 2. 33 divided by 3 is 11. Those are both prime numbers, so I know I can't reduce any further. On G, you don't have an option. You have to use your LCD because you've got a fraction being added to a whole number, right? Because that's a 1y and equals a fraction. You have to use your LCD here. Again, hopefully you're getting enough practice with these that you're able to see the LCD right from the bat. But if not, you've got 5 is 5 times 1, 5 times 2, 5 times 3, 5 times 4, 10, 10 times 1, 10 times 2, 10 times 3. What is the least common denominator? The smallest one is going to be that 10. Okay, so now that my LCD is 10, multiply everything by that 10. So here, 10 times 2/5. So 10 and 5 are both divisible by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. So now I just have 2 times 2, which is going to be 4. Okay, so again, one more time. 10 divided by 2/5. Cross reduce here. They're both divisible by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. So I've got 2 times 2, which is 4. And because this is all over 1, it is just 4. Multiply this term by 10. So we get plus a 10y equals, and multiply this one by 10. My 10's cancel, and I'm left with a -3. So now to solve, subtract your 4 over. Opposite of a +4 is a -4. So 10y equals -7. Divide by 10. And we get y equals -7 over 10. All right, and last one here. This is another one that is like this problem here. Or you can do it the way we did right here. Okay, so if you like this way better, use that way. But I'm going to go with this version here. You're going to get the same answer no matter what method you use. So here, first, before I even mess with the LCD, I'm going to go ahead and combine my like terms. So -7 minus 5 gives me -12. So I get -12z equals 6 over 7. So now my LCD you only have one fraction, that's 6 over 7, so your LCD has to be that denominator. So multiply everything by that denominator. So I'm going to multiply this by 7 and this by 7. You only have 2 terms. So 12 times 7 . 2 times 7 is 14. 1 times 7 is 7, plus the 1 is 84. And because it's negative, we'll have a negative 84z equals, my 7's here cancel, this just equals 6. And then my last step is to divide by negative 84. So I get z equals, look at this, can we reduce it? Yes, we can. They're both even, right? So if they're both even, ooh, you can't see yellow. If they're both even, we can divide by at least a 2. Okay. If we do that, oops, dang it, sorry. Hope there was nothing bad on that one. 6 divided by 2 is 3. Negative 84 divided by 2. 8 divided by 2 is 4. And 4 divided by 2 is 2. Those are both still divisible by 3. So divide by 3. Divide by 3. So my final answer is going to be 1 over 3 divided by 3 is 1. And then 3 goes into 42. 3 goes into 4 one time. Multiply it out. Subtract. Drop down your 2. We get 14. So negative 14. So my answer on that one is either 1 over negative 14 or negative 1 over 14. But either way, that one we needed to reduce. Really, we should have divided by 6 from the beginning. So that is actually all I have for this one. Let me know if you guys have any questions. And pause this video, rewind it as you need to.